Perfect. So thank you for kind of joining, guys. Yeah, I'll give you a brief introduction to myself, but of course, you guys are kind of here to see Jakub, so I won't take up too much of the time. I recruit for Go across Germany. It's my specialism, so it's the only language I recruit for. One of the things we do, you may have been to one of these talks previously, I run a series of webinars sort of across the network and things. Yeah, kind of hosting various topics. Today, I'm joined by the wonderful Jakub. He's talking about, obviously, as you can see on the screen, communicating with tests. What we'll do, we'll run through the whole presentation, and then towards the end of the talk, we'll start hosting questions then. Rest assured, the webinar is recorded, so anything you've missed or anything you kind of want to revisit, it will be live on our YouTube, and of course, we'll kind of send out an email kind of following the talk as well. But that's pretty much it from me, to be fair. Like I say, pretty quick introduction. I'll let Jakub sort of take over.
Hello, everyone. So my name is Jakub, or the Jakub for English colleagues. So I'm joining from the Green Island, from Ireland, close to Dublin. And so today we have an interesting topic, communicating with tests. So I would say it's a topic related not only to the technical skills and technical part of writing code or designing the systems, but as well we will talk about as well about the soft skills, where we need to actually think how our colleagues in the team, especially the new colleagues that they are joining our team, how they can communicate with us, how we can communicate with them, and of course, how they can learn the ropes in the project that they are joining through the tests. How can, for example, figuring out what's going on in the system, etc., etc. So let me start at the very beginning. So what we have in our menu for tonight. So we will introduce the small Go development team. There's three little lovely figures, goofers at the bottom. We will welcome the new member that then just joined the team, probably recruited by Amicus Recruitment. It's very likely. Then we will go through the couple of the code examples. We will try to figure out what Nick actually feels as a new team member when he reads these code examples, how he could interpret what kind of mistakes and conclusions he could take from these different examples, and possibly we could see how the other team members that they contribute to this code base could make Nick's life easier. So basically, let's introduce our team. So we have the Rob, which is experienced the guy on the Go team. We have Mary, she's very experienced developer as well. And because their company just signed new contract, they needed to hire the more developers. So, and here we go, meet the Mick. So Mick is an experienced developer from different languages. He's learning the ropes with the Go, and he's basically starting his journey diving deep into the code base and into the learning best practices and developing the functionality. So the main challenges that Nick faces, I believe many of us in this webinar were in his shoes or are in his shoes, is the conversation. He joined, let's say, the week ago or 2 weeks ago. He's doing a lot of paperwork with the HR, and in the same time, he's very eager to learn and contribute to the functionality. So the Scrum Master or the product owner already start preparing the new workflow for him. He knows that team members will help him, and there is a problem, right? The problem is that for the existing team members, a lot of the code base is familiar. They know where to look for the different functionality. They know what package to do, to touch, for example. They know where certain the dark corners of the code base can be hidden. It may be even some the tests are not covered. For example, I mean, some code base is not covered by tests, and for them, everything is simple, right? So we know these words that it's just a little trick, just a one-line change, and you can achieve certain results. Or it's very easy, right? It's not a problem. You just change this line, refactor this line, and we'll be okay. So it's usually fine for these team members. So when they already spent most of the time on the job and know, as I mentioned, all these different corners of the functionality packages, and that's it. So for Mick, this kind of the language and expression could basically make him even more feeling, level of anxiety, I would say, it goes up. Not only because he is learning Go itself, even though coming from the different languages, but he is basically trying to catch up with all this functionality, what's going on in the code base, etc., etc. So the most important for him is to start the learning, because he's eager to contribute to the features as soon as possible, as I mentioned. So he has a couple of choices how to start learning, and usually we learn in the same way. So the first of all, we need to figure out what this entire, let's say, the code base or the system that we are working on, what is the main functionality? What is the purpose? Another very important part is what is the data flow through the very enter to the system up to the output of the system. So he needs to have the 3,000 or 10,000 foot picture, like in many books they describe this, to have idea what the entire system is for, what's the purpose, and then start going deeper into the functionality, how it is implemented, how the data flow, etc., etc. So one of the points is, for example, is that he is usually learning going through the code, right? He can read documentation, hopefully up to date documentation. He can go through the docs that we are, of course, developing for every single exported, the method exported function and packages. So he can learn from this, assuming that all this documentation is up to date. And apart from this, he's going through the code. So the first, what he tried to understand is, okay, what packages, what functionality the packages provide, right? So what kind of the public API this packages exports. He's learning what functionality is used where, all these packages, the structure of the project, etc., etc. And what most important is he needs to figure out what kind of the behavior these different packages and different APIs provide. So when he starts learning, one of the main source to figure out what really is going on in the system is to go through the test code. And as we know, for the Go, the test code is as important as the code that delivers functionality. So Mick is encouraged to actually go through this test code and have a look, try to figure out what's going on. So let's follow Mick with this couple of the examples that actually I took from the real code base, open source projects. And let's have a look at what Mick can learn, where Mick could be, for example, tricked into some different misunderstanding of the code, and how certain improvements in the code make the Mick anxiety a little bit lower, and then actually bring him to the right path and make him to understand the code base better. So from this, we have the two tests here. From these examples, Mick can figure out that these two tests can be executed in parallel. So that's the main point for him. It means that we are not having any shared state that we could, for example, from these two tests, access in the same time, and we could encounter some, let's say, the race conditions. So if we wouldn't have this statement T parallel, Mick could think that maybe there is some dark corner, some at the top or the bottom of the package of the test file, some variable, for example, or imported, exported shared variable on the package level, that maybe we have some shared state. So the lesson learned from this simple example is that if we have the design that allows us to run this test in parallel, and this is actually supposed to be like this, then let's run this test always in parallel. So this is apart from the technicality, this is the first signal for the newcomer that, hey, we are not having here the shared state, we are ready to go and parallelize this test and run them and run them in parallel. Okay, so the next example, what Mick can learn here. So this is like a little bit snippet from the test code. We have some tests, and we have preparation, the data preparation, which is the CMD output. We have the call, we are calling some function, Mick see this, and Mick see that this function, as most of the functions in Go, returns the some data, which is in the got variable, and of course we are returning the error. So for Mick, it's the most important to see here that if we wouldn't have this fatal call, we would record the error on this function that is responsible for preparing the data for further assertions. And then we are going further, and the execution goes to our line that we have assertion, and we are starting asserting certain conditions based on data that we don't know what it is, and we shouldn't really care because our function returned the error. So the paramount lesson for the Mick here and for the entire team here is to always remember that when we are not sure and we are encountering the error from the function that returns the data that we use later on for assertion, is to always decall T fatal. So then the test immediately is marked as the failed, and we are not, for example, the going further and creating some assertions and making assertions about the data that should be basically pile of rubbish. So this is the most important lessons for Mick, that he goes through these different code bases and learn. So let's have a look at what else Mick has in store. So some developers, like in this team, or the developers that left, for example, team, they like the version, I would say, of the given, when, then. So it was the still it is the so-called the BDD, behavior-driven development, and a lot of frameworks around the Python and Ruby and for example, the Java JBehave. I believe the C# has the similar framework, that we are expressing our conditions with these three actually the words, that given certain preconditions, when something happened, then we are expecting certain outcome from our tests. So I saw this examples as well in a couple of open source projects. The question is if it's too overwhelmed for the readers that is new to Go and going through this, or not. So I'm not judging this. This is the matter of taste. Everyone has their own style of writing. We all strive in Go community to basically write the code as simple as possible in order to achieve results. So apart from this, Mick knows that he will see this log messages only when the test, of course, they fail. So when test pass, test is silent. So this is the golden rule. This test should not be basically chatting. If we have the error, we see the error. If test pass, we see basically nothing. So for some people could be overwhelmed. If Mick, for example, Mick likes this kind of scenario, and for him it's okay, he is good to go and figure out, for example, how to add or how to learn about the system with this way of presenting the preconditions and actions and then expected results. So another situation, so assuming that this system is using somewhere the database, so we have package that deals with database, and what Mick sees here. So we have the function that is responsible for creating the database. And what is in general, what is helper? So he starts digging into Go documentation, and he knows right now already that this function will be used somewhere in the test. We will see in a second. But the helper helps him to, first of all, to have the first clue that if this function fails, his main test won't be reporting that failure was somewhere in the random function like this one, but the entire test will fail. The big advantage here of the functions that they are test helpers is that we are passing here as one of the parameter our struct t, and then we are marking this function as a helper, and we don't need to return from this function, from this helper, any errors. So what Mick will see, as I mentioned, we will see in a while, but the most important here, the takeaway for Mick is that if something is happening during the preparation, the data preparation for the test, he will immediately see the error. And if everything is okay, he will get his database up to the test, and then he can continue. So the second part of this example is that we see here right now how this test helper is used in the broader picture of the entire test. So the mix is here, okay, we have some tests. He sees, okay, test is executed in parallel. We are happy we don't have any shared state. And now we have the code that is responsible for preparing database. So he remembered he was going through the different examples of the different code bases, and he remembered that in many cases, he saw, let's say, 50% of the test function was occupied actually by just the code that was responsible for creating preconditions, create files, create databases, like in our case. Then every single creation, of course, returns an error. We need to catch this error. So we are spending a lot of time trying to, assuming we are spending time with Mick, right? So trying to figure out, okay, we are handling the error responsible not for test assertions, the business logic of the test, but for preparation of the data for the test. So here, using the test helper allows us to basically to have the test code focus on the business logic and assertions and abstract the creation of the preconditions for the test to the completely different function or method. And then if something happened at this stage, the entire test, this one, will be marked as fail. We don't need to go through these different assertions. If everything is okay here, Mick sees that this database is passed to the struct, and then we have some business code later on here omitted, and then the database is created, preconditions are created for the test, and we are ready to go and start creating the assertions and checking if we have errors, if we have some conditions they met for our business logic. If everything is okay, Mick understands. Most important, as I say, is that we are reducing the code bloat required for the setting up preconditions and not for the business logic of the test. So let's have a look later what is happening. So what is the cleanup? So Mick was going through the test code that we just seen and was thinking, okay, we are creating database, but what is happening with database when the test finished? Be this error, or for example, everything is okay, the test pass. So the question is that Mick was learning the Go, and he see it, and he, for example, he was accustomed to the pattern that after creation of this database, we were calling defer, and then we had some function that was responsible for cleaning up the created resources for the given test. Could be file, could be database, like in our example here. So what this cleanup allows, and Mix is learning here as well, that we are allowed to attach the function that will be executed automatically after our test is finished, be this with failure or with success. So some developers and some engineers think that this is too much magic for the Go, and they prefer to use the defer statement inside the test function body. But this cleanup method is very, very neat and very, very handy, just to be sure that not to forget to clean, defer, and leave some resources, for example, not clean up. And we are making sure that anyway, after every single test, this cleanup will be executed. Either the database will be wiped out, like in our example here, or the, let's say, files will be destroyed, or we can use this cleanup as well and set up the methods to create, let's say, test server, if we need to stand up the server only for the given test. So another example that Mick can learn here, and as well he can get confused here, is to start reading tests that they deal with the prepared data files. So he could work for the company that they are dealing with some, let's say, configuration setup, or they have big data sets that they need to be used to compare with results of generating, let's say, configuration files or generating certain data. And we need to compare them and base it on this comparison to decide, okay, we have the failing tests or passing tests. So the one of the source of the confusion for the Mick, and this is actually the main work for the experienced developers on the team, is to make sure that the name of the data file matches the name of the test, at least either tests or the package that we are testing. Mick seen very many repositories that we have test data 1, test data 2, up to test data, for example, 300. And these different files as reference in the different test code. So Mick, I don't know if he would be happy going through this code and trying to figure out, learning the Go, learning the business logic, and trying to figure out why certain test is not failing. Maybe because someone, instead of 001 data.txt, put, for example, 0001, or mixed, let's say, 001 with 011 name of the file. So the lesson learned for Mick and for the entire team is to keep consistency. The naming consistency, not only in test, is very important, that we are naming the variables, naming the structs in the short and meaningful names, but we keep consistency between the names for the files, in our case, test files, and the data that this particular test files test case consumes. So it makes the learning process and figuring out why the certain test pass or fail much easier. So then Mick concentrate on the learning of the business logic and learning functionality, not trying to actually figuring out why, because of some silly mistake, why something is not working. Let's have a look on another example. So Mick is going through the system. He's learning functionality. He sees a lot of tests that have a lot of table tests. He sees the tests, like many of us, that, for example, they have 30, 40, 50 different inputs in the table tests. And what is as well quite important, some of these inputs in terms of the structs could be, let's say, half a meter long, let's say. So, or you need to scroll for half a second your screen in order to figure out how big the input for the given test is. So the problem is that when new developers start looking through this test code and figuring out why something is not working, they believe that the function itself is working correctly. But it's not always the case. We have, let's say, the table test with 10 different inputs. So Mick goes through this, reads, trying to figure out what's going on over there, and something is failing. But Mick doesn't know why. And there is no information in table tests why certain parameters make the test the test fail. It means our function is not working properly. So for Mick, the most important question is to always ask, what are we really testing here? So instead of, at this moment, see this method or the test function as a black box and add additional assertions or additional, let's say, the case to the table test with some additional the changes, and making sure that this test pass. The main question is, did actually someone from the team seen this test failing? Maybe Mick, maybe some new developer that will be joining, they are following the pattern of adding some condition to the stable test, and they are happy because the test is still green. The question is, why is green and why is not red? And the most important is curiosity at this moment, and this learning experience of the newcomer to the team, and trying to figure out under what conditions this particular test would fail. And that's the reason Mick is going through the code base, apart from going through the test, and trying to figure out what actually the business logic we are talking about. And Mick's open one of the open source projects here and see following example. We have some function here, and we are getting some parameters, and we are returning some values here. And as always in Go, not always, but one of the we return the error basically. So here we have the error, and the business logic of this function. When we go through this, what we see that this particular function always returns the error that is nil. This function sits somewhere in the dark corner of the code base, but this coroutine could be used and is used by many other places. What is important, this method is exported. It means that this package provides this function as the one of the API. This is part of the API of the package. It means that this imported package will be a part of another package, for example, or another some functionality that we are coding. What follows? Every time we are writing tests, we try to figure out, okay, under what condition this particular function will fail. It means that we are writing the assertions. We need to assert that we have an error or not. And basically, this is the one of the example of the call from the code base further in the same, actually the file, that in the different place, this entire method is called. And what is interesting, we spent additional time Mick is going through these functions. He reads this, spent time trying to figure out business logic. And it turns out that we have dead code at this moment because we are asserting something that always will be nil. We are creating the unit tests for something that always will be nil. We are putting this particular function in some table tests that we know after this check that always will be nil. So for Mick is the very, very valuable lesson from this actually exercise. Never ever trust, just always verify what is really going on inside the function. And one of the example how to do this is create a fork, and Mick starts actually playing with this test by changing different input data and trying to observe under what condition this particular function would return an error. And this applies to many other examples that he sees in the code base, where actually changing different input, he doesn't see the function fails. And this is the first red flag for him that something fishy is going on. And basically, he needs to put his Sherlock Holmes hat and start to exploring more what is going on inside the code base. So the most important is here the lesson for him, that this could be one of the first, actually, his PR when he joined the team to fix this problem by changing the signature of this function, remove this basically useless code that is only bloating code base and creating the noise. And what is the most important is he would make the refactoring, and we won't have function that returns an error. So if we don't need to return an error from the function, let's not do this, because it will allow us not to handle error, something that basically it doesn't exist. So let's have a look further. Now, one of the packages that they use in the code base, it's the package CMP from Google. So what Mick is learning is that in this code base that he just jumped and work with the team, they are not using any extensive testing frameworks like he used to be when he worked with the Python, Ruby, or any other languages. So he heard that Go community loves simplicity and likes to rely mainly on the standard library with the help of as less as possible these different packages. So let's have a look. What is the CMP? This is as I mentioned, very simple package, but very powerful, that allows me and the other team to start writing the tests and verification of the tests, checking the errors, and specifically on output that, for example, there is some JSON file or huge or smaller or larger structs produced. So what is most important here is that in this scenario, in many code bases, we are using the reflect package, and then let's say comparing structs. What Mick sees is that in many cases, when he observed the failing test that uses the reflect package, he sees addresses. Address of the struct, address of the, let's say, the required struct. For human, it's pointless to display this because he doesn't learn, Mick doesn't learn anything. He sees addresses in many cases, but he doesn't see actually the human readable values. He is not able to comprehend, hey, I am missing the value in this struct that should be, for example, 40, and I'm getting 41, or some different string. So the package, the CMP, allows us to create quick assertions, and the output, like we will see in a second, tells Mick what is really going on and allows him to quickly refactor the code, fix the bug, and observe the proper assertion and scenario. So going most used here, most frequently used, they are the two methods, basically the equal and diff on the CMP package, like Mick learns here. So the first type that Mick sees here is that we are generating diff at the very beginning, then we are checking if this diff is the empty string, and based on this check, we are failing or not. Now, Mix goes to the CMP documentation and figuring out that there is a little bit easier way to do this, and for many, including Mix, this would read a little bit easier. It means that reading English, we have, if something is not equal, in our case is won't and got, or got and won't, then we are attempting to generating diff, but not before. So if something is not equal, we are generating diff, displaying to make the difference between the expected and not and got results. If something is equal, we don't bother with generating diff. Happy days, test pass. Now, if test is failing, what Mix sees here is the diff between expected results and the results that he got. In our case here, we have the struct that describes some geographical place in Ireland here. And we see that, for example, we expected the elevation 42, but we got 41. And Mix sees this clearly. And this is human readable output that allows to Mix to immediately go to the function and check how these values are calculated, rerun the test, and if test is not producing any output, we are fixed and everything is okay. Another interesting example is when Mix starts going through this code base. In many assertions and in many errors, he sees very, very long strings. Apart from this, in these strings, sometimes we are embedding the structs as the value that we use to generate this error. The problem is with readability. If test pass, everything is okay, we see nothing. But if tests start failing, now Mix sees basically a lot of junk on his black screen, and it's very, very hard to comprehend what is really going on. So one of the solution is to move the name of the test as one of the field in the struct that is used in the table test, here marked as the TT, and then use this name or description of this data used as the input as the testing name. So if this test will fail, the Go tooling will nicely print out the main test name plus the name of this struct that we used. And then on the other hand, Nick sees here just simple check for equality in our case. So he doesn't need to read a lot of code, because anyway, if this error happens, Go tooling will print out nice name of this particular failing test. Another lesson learned for Mick. Another example of the test helper. So Mick is going through the code base and start asking, what are we really testing here? So I remind, this is one of the most important takeaway from our meeting, just to be curious and always ask what we are really testing here. So this is an example that Mick says that business logic in the test is a little bit bloated by creating preconditions. So here in our case, we have some test configurator needs to be created for our tests, but test configurator returns an error. It means we need to handle this error. And what is most important even here, that we see that we allow to test continue even if the test configurator is not created properly and returns an error. So if we are going ahead with this situation, so Mick already thinks about his PRs. how he could fix this together with the team is basically either change the error F to fatal, and then we bail the test immediately, or to refactor this method in the same way like we've seen at the very beginning of our meeting. So he creates basically refactors this test helper, change the signature, passing the test, mark this function as a test helper, and just in case this new configurator is not created correctly, we are bailing immediately and returning only correct configurator. So at this moment, we know at this line that always CNF will be properly created. And then we can continue with the business logic and with test assertions and verification of our test data. So this is very important for me, because it basically allows him to figure out what is the main business logic in the test without reading too much and spanning his attention through different stages, like creating test preconditions, then assertions, and then verification of the data. Now he goes through the code base and he sees a lot of tests with table tests. The problem is that some of those tests are hard to read for him and hard to comprehend. The another problem is that they work in the distributed manner. Some of the team members, like many of us, are working remotely or traveling. It means that our communication is usually asynchronous. It means that when Mick doesn't have at this moment, for example, someone to talk and ask the question about the code base, he needs to spend time trying to decipher what is really going on in this test, why it's failing, or why particular the input to this function should fail or not. So he needs to wait additional, let's say, couple of hours until he reaches one of the team members and they can explain. So this is very important lesson for the entire team, to keep the negative scenarios and positive scenarios as a separate tests. It allows me to figure out very quickly and to learn very quickly, hey, we are dealing here with the set of negative inputs. Every input from this table will cause make my test fail. On the other hand, when we have positive inputs, every single input is supposed to make the test pass. So in our case, we have the simple scenarios here, like cases like here, right? So Mick knows about the different values to exercise the tests around so-called boundary conditions or equivalence partitioning of the data set that is that this particular function process. And he is able to, for example, figure out what data to put, and assuming that this data is correct, then create a set of positive test cases, like here in this example, and negative test cases, and separate, refactor, let's say, this bloated test that mix test data with the correct values and not correct values from one test to two separate tests that separate this business logic. Now, having these different scenarios, positive and negative, in one table test can be seen by experienced people or experienced developers, that they are accustomed to, let's say, add certain data, see this test pass as a way to go. The problem is when we are coming back to this code base after months or years, or we have the new team members like Mick, and people start to read this in order to learn about the behavior of the system. The problem starts that the more convoluted and mixed the data we have in one table test, the more convoluted business logic in our test we need to start creating here. Here we have only two examples that we mixed positive and negative tests. Now, if you are working or Mick is working on the code base that, for example, is open source, some piece of software, and it's the same version, maybe this company deliver as well paid version and some functionality slightly differs. We have additional 2 variables to mix in the test table. Then we are ending up in having one big test with mixed the values already 4 different variables. It means that we need to start making the assertion logic in our test more convoluted. First of all, it's prone to errors. Secondly, it's much harder to learn. So let's make the mix life easier and refactor this test together with him and separate this business logic. Coming to actually one of the last lessons for the Mick when he starts and the entire team is basically a never-ending story about how we are supposed to name this test, how we are expressing what kind of the behavior of the system we are testing. So in order to test how are we doing and how is doing the Mix team, I would highly encourage to install this great package. It's called Go Test Docs, and run our test suite through this tool and figure out, do we really understand what are we really testing? I will show in a second certain results, but the most important is to start thinking about our tests are the execution of certain system behavior and describing them in the, let's say, so-called ACE. So we have the action, what's going on, we have condition, under what, for example, value of circumstances something is happening, and what kind of expectations we have on the test. So then when Mick is reading this test, he knows that if I put this kind of data, I can expect the failure, I can expect the test pass, etc., etc. Let's move, this is the real package, open source, run through this test tool that will help us to decipher if we really can get the meaning of the behavior from our tests. Have some parameters. Determine updates, right? So this is usually the naming convention seen in the most of the code bases. But this tool really helps to figure out how we can name this test in order to express behavior that will be clear not only for Mick, but for, let's say, the testers or business people that they are, let's say, tech savvy, or the product owner, and then collaborating on this project. So when we are running this tool quickly, we see if we can understand the certain behavior. So this is another example of this tool. So we have slight improvement that describe what's going on. Let's say buying formats, whether info on valid input, or the client request whether with valid path and params. So it helps us to actually structure our test into the proper English sentence that describes what's going on, what kind of assertions, and what we should be expect. And the most important takeaway is for me and for the entire team, not to fear longer test names. So after the test, we are adding this different description that this Go test tool automatically translates into English sentences, and we can clearly see what is going on in the system without actually going and employing here any BDD frameworks from other languages, even though in Go has a lot of the test frameworks, but we don't need to use test frameworks in order to produce clearly readable and understandable, basically business specification for our tests. So just to summary for the Mick and for all of us, I would say, read code. The more we read, the more we learn, the more we understand. So I would say we should read more than we write. Let's strive to write code for humans. And we know this mantra in Go, write the simple possible code. Machine and compiler will understand. Other human with the different cognitive abilities, maybe newcomer, maybe someone who is completely new to programming is joining team and is learning, or is trying to, for example, contribute to open source project that we are involved with. Allow newcomers to clearly understand our intent, what this business logic means. Always keep readers in mind, right? So writing the docs, writing the documentation, especially for all the exported the API from the packages. And always write documentation with the focus on why is something happening. So let's encourage Mick to keep refactoring, even if he just joined the team. And remember this, one of the most actually important talk from the Rock Pike. Simplicity is complicated. So this simplicity and complication is simplicity applies not only to Go routines, but to writing as simple as naming functions and especially test functions, and expressing our intent in the business way to make it easy to understand for whoever is coming new to our team, and for Mick and for other fellas. So that's it from me. Thank you very much. I have couple of resources attached here that I use in this presentation and use on the daily basis in my at work. And here is quite a large number of books that I would really highly recommend on this topic, not only about the technical part, but as well about the business part and how to think from the simplicity, psychology point of view about the programming, and how to actually interact with the different humans on our team and see people, engineers and the business people as humans. And books that in men, especially like Psychology of Computer Programming or Bridging the Communication Gap, they are brilliant books about how to communicate with the team members using technology. That's it from me. Thanks a lot.
That was wonderful, Jakub. Thank you very much for that. As mentioned at the start of the webinar, yeah, we've got a little bit of time now for some questions, if you have any to sort of come through. First question we kind of got midway through from Alexander there. He was asking if we could provide a list of these packages somewhere. Of course, sort of following the webinar, I'll send out a quick email to everyone that attended, just the YouTube link, etc. I think Jakub also mentioned that he'll also attach the slides of this webinar too, as well as obviously the list of packages that he mentioned.
I will upload this presentation to my GitHub account. I will create a repository and then send the link to David, and David, to Graeme, and then Graeme will be able to actually share with you all these resources. So all these links to packages will be available. I didn't include the links to books, but titles are easy to find out on whatever the store you are using, either online or not online.
Or otherwise. Okay, brilliant. And of course, we will obviously share in the coming days, obviously live on our YouTube channel and stuff as well. So you got a full recording in case obviously anything was missed, etc. Also keep an eye out on LinkedIn. I'll keep a short post up there. I'll tag up Jakub's GitHub account too, so everything can be sort of found through there. I think that's it so far from the questions that have came through. Does anybody else have any kind of quick questions? Or was all that quite clear? I know for me anyways, it was all quite clear, the parts that I understood at least. Perfect. I think that's it for questions, to be fair, Jakub. Obviously, like I say, yeah, Andrew as well, thank you, saying thank you. That was great. Really enjoyed it. Yeah, I definitely copy that sentiment. But okay, perfect. That's pretty much it from me, like I say. Do you have any kind of final comments, or is that kind of everything round up, do you think?
Also, I really enjoy. I love Go. Started working some couple of years ago, and I really, love the simplicity.
Nice. Yeah, of course. Like I say, it's something language I recruit for. So yeah, I definitely love it.
Yeah.
Perfect. Well, okay, guys. Well, thank you very much for attending.
Thank you very much for coming over. I hope you will find this useful.
Yeah, for sure. Pleasure, obviously, having you again, Jakub. Thank you again for joining. Of course, a returning guest. And again, I'm sure, yeah, pleased to
Have
have
a
you again
lovely
at some
day. Have a
point.
lovely evening. Thank you very much.
Have a brilliant evening, guys. Thank you very much.